Hello, thank you for being here. I'm happy to be here. I'm going to talk about security, but from the point of view of testing engineers and a little bit of development engineers. So I'm not a security expert, disclaimer, I am a tester. Don't trust me on everything that I say. Feel free to double check everything. So let's get started. Imagine that you are a developer and you're working on your favorite open source library, or more important, you go to work from 9 to 5, Monday to Friday, and you work on the company product. This is what you're going to do every day. You Google, okay, how do I solve this class of problems? And you find some libraries. You go to GitHub or to the website of these open source libraries, or maybe they are commercial libraries. You read a little bit about the documentation. You read the API docs to see how to integrate. You find a couple which you like, and you pick one of them. Download it locally, write some more code to integrate with the existing software, push to production. This is basically the process. And this is what happens. On the next day or sometime later, you wake up, you open Reddit, and you see, oh shit, the library that I just deployed to production has a security issue with it, it's critical. This is from April this year. The SSH decorator package, which was discovered to have a backdoor inside of it. And in here you can see it tries to steal your SSH keys. And not only that it steals your SSH keys, but it sends them here on HTTP connection, so non-encrypted HTTP connection. And everybody who is listening on the line, they can also get access to your keys. So very, very bad. Unfortunately, when I saw this post, the package was taken down from the internet, so and the GitHub repository was deleted, so I don't know what is the history and how this happened to be. There's another more recent event that Mikhail sent me. That's from about 10 days ago. So this guy, Dominic Tarr, created Event Stream, which is a Node.js package, apparently very, very popular, and he didn't maintain the package for several years. And some guy came in and told them, hey, I want to help, let me help. And Dominic gave them full access to GitHub and to npm.js to publish new versions. What the new guy did was basically add some payload into the source code, which is along the lines of mining cryptocurrencies and sending them to their own cryptocurrency wallet. Released a new version, then deleted the modified code from GitHub, pushed again. He also deleted access for the original author. And this was very popular package. For 2 days, it got several million downloads. And now imagine all your websites are probably mining Bitcoins. And the response from the original author is somebody opened this issue, and he says, well, this guy emailed me. He wanted to maintain a module. I don't care. I gave everything to him. And this happens all the time in the open source world. So you cannot trust people. There was also a similar security issue with Django attachments. They have denial of service problem. And the problem is Django attachments is a library that deals with attachments if you are using the Django framework. And when you upload files, it has a feature to check for how much files you have uploaded. And if you try to exceed your quota, that's a setting, Django attachments will tell you, hey, no, you cannot upload more files, which is fine. And the way they do it, they store the content of these files on the file system, and they also store information in the database to make the checks faster, because reading from the database is much more faster. And when you delete these files, they delete the entry from the database, but they don't delete the actual content on the disk. So I can upload and delete and upload and delete and upload and delete, and you can create a very simple script to do this. And in the end of the day, this application will either have to pay tons of money to their cloud storage provider, or they run out of disk space and the application stops working. So this is what happens. And of course, I had a similar security problem with my own open source project, KiwiTCMS. We were logging passwords and usernames into the database, which sounds very stupid. And this is how we do this. We have an API layer. And this is the class handling the request from the API. And we thought, let's be good people and try to log all the API calls in the database for audit purposes and debugging purposes. When somebody complains what is going on, we can go back and see what is happening. And this is our function log call. We log the HTTP request and the method name and the parameters. And some of the methods are authentication login and user.update. And the first parameter is the username, the second one is the password. So, stupid. And on top of that, we have another RPC handler which serves the same API interface on different protocol. So 2 different endpoints with the same functionality. And these 2 things, they can diverge over time. So you fix the problem in one place, and then you have the same problem in another place if you're not careful. So this happens very often. And my point is, everybody has security problems. So everybody, all the time. And I say that it is our job to help with that. This is how the modern development and testing lifecycle looks like. So this is from this blog, some guy in the UK. So with blue, you have all the development and release steps, and with green, you have testing. And we can test at all different phases. A lot of companies are already doing this, testing in production, testing while monitoring, etc., etc. And the trouble for us testers is that already we are getting out of our comfort zone. We are getting into fields where we don't really feel comfortable, where we don't have enough knowledge. But it is our job to test, because, you know, testing, it needs to be done. Somebody needs to do it. The good news is we have the analytical mindset to deal with all of this, and we can learn how to do it. And I say, with the green in this picture is testing, and I say add a little bit, a pinch of security everywhere, so we can help. I'm going to talk about the application under test and how to think when designing test scenarios. I'll give you a couple of examples. I'm going to show you lots of static analysis tools which can help, and you can integrate them very easily into your CI infrastructure. I'm going to talk about software dependencies. This is the software layer which is under your application under test, and why this is important. If you still haven't figured out why this is important from the previous example, we'll see other examples as well. And at the end, I will just briefly mention testing infrastructure and why that's important to be secure, and leave you with an idea what we can do about usability and security. And yes, this is something else that can be tested, something else that we can be part of. I'm going to show you lots of examples from Kivity CMS project. This is an open source test case management system, and I am the project lead of this thing. This is very old software. It's almost 10 years old. And the original team that created the software, they later abandoned this, and my team adopted it. And we decided, okay, let's look at this old piece of software. Let's figure out what's wrong with it. Let's make it, you know, better. And we discovered a lot of problems along the way. So first things first, how to analyze software under test. This is what we do every day. We analyze requirements, we try to figure out what is the product risk, and we try to design test scenarios, test cases from that. And think about a modern application, what properties it has. It has all of these properties. So who can work with the application? We have users, we have groups, we can have organizations, we can have multi-tenant architecture, so one software deployed on one server, but different groups can use it, and they can only see their own data in the software. And all of this is usually designed with some kind of permission system behind the scenes. So who can do what and where? Then points in the software where users can interact with that. These can be API endpoints for API clients, for automation. We can have HTTP request handlers which return information back to the browser. So this is how we people usually interact with web applications. We have user interface which can show or hide some menu options or buttons, or enable or disable based on our permissions. And user interface usually is created with templates. And we have different actions which, you know, the standard create, edit, delete objects. And the one at the end is modify related properties, which we sometimes don't think about. For example, in Kivity CMS, you can create a test case, and you can apply tags to the test case. So test case object and tagging objects, they are 2 different objects. They are saved in 2 different tables in the database. But because the relationship is many to many, we have a 3rd table in the database to keep the relationship. And depending on your application architecture, on your framework that you use. We use Django. In Django, this needs a third set of permission labels, third set of handling actions, functions on the backend that handle this. So it is possible to modify the relationship between these two objects without modifying the objects themselves. So this is yet another thing that needs to be tested. And in the end, we have the distribution layer. I'm not going to talk about this. This is how you deliver your product to your customers. If you're building Docker images or cloud images or something like that, you need to be very careful. There is a lot of information on the internet from all the cloud vendors, how to build secure images. So this is yet another thing that you can read about, yet another thing that you can test and make sure that it follows all the guidelines. So a couple of examples. All of these examples from the project, we discovered them simply by thinking what kind of scenarios we have to design for this functionality. The first one is bogus permissions in the API layer. So you see we have the create function and the add tag function. They have the permissions required decorator. And they check permission labels. You can notice that the permissions labels are different. So these are the correct things in this scenario. However, look at these three lines, which have been actually copy-pasted between the two functions. So the problem in this example is I can create an object in the database, and depending on what values I sent with the HTTP request, I can create a second object and make relations between the two. And these are two different actions. So I have permission for only one of them, but I'm performing two different actions in my function, in the create function. And there's a number of ways to fix the problem. I can say, well, I want the create function to be able to do these two actions, so it needs to check the two permission labels. What happens if the user has only one of the permissions? Do we allow them to perform the two actions or not allow them to perform any action? It depends on your use case. I can reuse the second function into the first one, and it will magically take care of permissions for me, which is a nice option. Or my preferred option is I delete this functionality and I update the documentation telling the user, these are two different actions. If you want to perform the two of them, first make the first API call and then the second, making things a little bit more simpler and a little bit harder for the user. Another example is bogus permission in the HTML template. So we have this button and we want to hide the button if the user doesn't have enough permissions, which is fine. We have this conditional statement in our templating language. The trouble is we check the wrong permission label. And if you design test cases, so let me test how this page looks when I don't have permissions, the button will not be there. If you design a test case which says, let me see how this page looks when I have all permissions, the button will be there and it is going to be fine. And you need a third test case, which is exactly that permission, the one you need. Because if you test with nothing and you test with everything, you're still not going to find the problem. And a lot more examples. You can find this into our Git log if you want to. We had several functions which handle requests from the browser, and they were missing the permissions required decorators. They don't check permissions. They rely only on the browser to show the buttons and the menu options for this action, which we saw that can be wrong. And on top of that, these functions on the backend, they were also missing login required. So you can use them without even being logged in. So very stupid. So why I'm showing you this? Yeah. So every company is a software company, and including Omský Měsokombinát. And also, your metro station has more Git commits than you have. So, yeah. So even if you are, if you don't know anything about programming, even if you don't know anything about source code, how applications are built, maybe you're just starting your career, you are a manual tester, this is a very good opportunity to learn. And the truth is, you will not survive in the software testing industry without knowing how software works and how it's built and what happens under the hood. So that's why I will continue with a lot of examples which include source code, because this is the easiest way to explain that. The first tool that I want to show you is called Bandit. This is for Python because we use Python, we like Python. And it's a very nice tool. The ideas from this tool can apply to other languages with other tooling. And Bandit was initially created by the OpenStack project. And OpenStack is something which enables you to have cloud infrastructure in your data center. And they figure out, well, our software runs in the biggest data centers in the world, so it must be secure, but we don't have the resources to spend on a huge security team. So let us create a tooling which will help developers avoid some common mistakes. And they created Bandit. And Bandit will look in your source code. It's a static analysis tool. It will look for coding patterns that are known to have problems. They may not be a particular problem in your environment. Bandit will look for things like, this is a very short list. So for example, the exec function and the eval function, which happily just read the input parameter and try to execute this as a source code, which is always bad. Then we see a bunch of functions which have to do with SSL and secure requests. If you're doing HTTP connections over SSL, but you don't validate the other side, this can open you up for man-in-the-middle attacks. So it doesn't matter that the connection appears to be secure, it's not. And my favorite at the end is Django raw SQL used. In the Django framework, you don't work with the database by SQL statements directly. You use classes and methods in these classes. And Django will translate that behind the scenes to an SQL statement. And it will try very hard to keep you secure from things like SQL injection. And if you use the raw SQL function in Django, you can pass some string directly to the database, so basically bypassing all the security functionality that Django gives you. And it's effectively as if you're writing PHP. So all the good things about Django can be bypassed with a single function, and it's not considered a good practice to use this function. So, example number 1 from our project, remote code execution. This is the most critical example that Bandit was able to find. So we have this function. I have simplified a little bit to fit on the slide, but basically Django will detect the exec function, and what it does is it will read the content of the HTTP request from the browser and happily try to execute this as Python source code into the address space of the application. So you can exploit this very easily by resetting all user passwords in the database, or you can delete everything. And in fact, on our demo side, we had somebody that deleted everything from the database. I don't know if they exploited that particular problem or some other problem, I don't know, but they deleted everything. And if we look more closely, so this is very bad, absolutely bad. We have to fix it. And the way we fix it, we start looking at why this function even exists. What's the bigger picture here? What the original author wanted to do? And we see it tries to import something, some module. It loads a class from this module, creates an object from this class, and renders the class back as HTML to the browser. And if we look at the front-end interface, well, that function was always used with the same parameter. So instead of having that ugly function, we can have this. It's the same thing. Create an object from our form class and render this as HTML back to the browser. And we can go even one step further. Just create this as an HTML file as a template without any piece of code on the back end, and it will be fine. So it's static, it's much more secure. So yes, people make stupid mistakes when they create software. Another check in Bandit that I like is hard-coded password. Bandit will look for functions which have a parameter with the name of password. And if you give it a hard-coded string, Bandit will give you a warning. This is to prevent you accidentally, committing something to GitHub. So maybe you were testing and forgot to delete your testing lines. Bandit will find this. Be warned that there's going to be a lot of these warnings from your test suite. And you have to ignore them in the test suite, but you have to examine them one by one. And there can be many false positives, and it will take you a lot of time to examine all of them. Another problem that Bandit finds is hard-coded temporary directory, like here. We were using this directory. Well, The problem with hardcore temporary directories is on Unix systems, and I believe maybe in Windows as well. In the temporary directory, everybody can create files and directories. And if you know what the application is looking for, you can create this directory, possibly point that to some other directory, and it can happen that application can destroy information or accidentally expose some information that it was not supposed to. So, don't use hardcore temporary directories. In our case, this is not a particular issue because we deliver the software as a Docker container. If you have access to the container to create the temporary directory, that means you have access to everything, even to the database. But we had bug reports from users who don't like to use Docker, and they deploy our software in a different way. So we have to fix this problem. Maybe not very urgently, but we have to fix it. Another pattern is try except pass and also try except continue. And the way to fix this is don't ignore the exceptions. Let the exceptions propagate. And there is another presentation by Yegor Bugayenko about not ignoring the exceptions and letting them propagate to the outer layer. This is a link to that presentation, very good presentation. In the context of security, that means if something bad is happening in the application, you will learn about it. If you ignore the exceptions, you are not going to know anything. That's the idea. That's why Bandit tells you don't ignore them. Ideally, you will have some kind of logging system or monitoring system like Sentry, which will tell you, hey, this exception happened. Look at it. Here's the traceback. Here's the information. Figure out what is going on. And I have an example. In this case, it's maybe not very clearly visible. We have a value error which is trying to convert something to an integer. The value is TC1 for test case number 1. We try to convert this to an integer number. The place in the source code where this is happening, we have a form which is submitted from the user, from the browser. It is valid. So we try to create a query against the database using the fields from the form. So we accept information from the user, send this directly to the database. Now, Django is clever enough to prevent these kinds of things. It will see that the field is of type integer, and it will fail. And I don't know if the user typed in something incorrectly, or this is a very clever way to disguise their attempt to probe for SQL injection. I don't know what is happening, and I don't really care. The moment I see this exception in my logs, I go to the source code and I fix it to validate this field as an integer in the browser. And now the user will get an error in the browser. The function will exit on the previous line, so the form is not going to be valid. And that's the way we fix the problem. We don't care what the user tries to do, if they are malicious or just stupid. Another nice thing about Bandit is they keep a blacklist of a lot of modules and functions which are known to have problems. First one is insecure hash function. So in our example, we are using SHA1, which is a good hash function, but is now considered insecure because researchers already were able to break this function. And if you look more carefully at the function that this piece of code is in, this is the function that generates some kind of random string when the user registers an account on the web app. And we send this to their email to validate the email account. So it doesn't really matter if I use SHA-256 or something stronger in this function. It's probably still going to be fine. But let's play along with Bandit and fix the problem. We change SHA-1 to SHA-256 just to be safe. We move on, and in the same function, Bandit tells you, oh, you've been stupid again and you are using random. And in computing, nothing is really random, especially when you deal with security cryptography. You should not be using random. And obviously, this is what we were doing. And look at the lines in red. We are not only using random, but we are using random in a very stupid way. So we create an integer number, and then we convert that to a string. And then we apply checksum, which is SHA-256, which is a very long string. But we don't take the long string, we take only 5 characters from that. And we call this a salt. So the beginning is only 5 characters. And then we append the username to the salt, and take another checksum from that, which is not only stupid, but it's also slow, because some functions are slower. And this is what we send to the user to validate their email. Well, in every modern programming language, there are modules and functions designed to work with passwords, with secure tokens, and things like that. So don't reinvent the wheel. Don't try to be clever. Just use whatever is available in the language. It's probably much more secure and much more well-tested from whatever we can create as developers. On Python, this is a module which is called secrets. This is what we use. And yes, don't use random. And the last example from the application is parsing XML. Apparently, the standards module for XML in Python are very bad, and they are not recommended to be used. And there's also example from the Rails projects. So that's Ruby. You need to look up these numbers. This is basically the same problem in Rails found in different places in their source code. They parse YAML, not XML, so again. And the lessons here are parsing file formats is very hard. Even established open source projects make mistakes, and these can be exploited later. If you have functionality in your application where the user will upload a file, and you try to parse this file and input the information in the database or do something else, be very careful with that. You need to test this thoroughly. If you're using some function which your developers created by scratch, then probably it's missing a lot of edge cases. So you need to be careful. If you're using a popular library, make sure this library is the latest version. Keep monitoring updates for this library when they have security announcements available, because these things happen. And the other lesson that we can learn here is that if you have an API layer in your application, which pretty much every application has nowadays, and you have import and export to XML, CSV, JSON, well, you don't need the two functionalities together. You need only one of the two. And my vote goes for remove all the machine-readable file format functionality in your application, because the only reason these file formats exist is to facilitate communication with other systems. If you have an API layer, this can be done much more easily and more flexibly. So remove all machine-readable file formats functionality from your application, and you also remove all the security problems associated with these file formats. So moving on to the next tool, which is called Coverity Scan. Some people I know have used it. This is a commercial tool. It's not open source, one of the few non-open source tools that we use. We use Coverity Scan for absolutely everything at Red Hat. And it's also used by several other big open source organizations. It's used by the FreeBSD Foundation, by the Linux kernel team, and also by the Apache Software Foundation. It is a really good tool. It's a static analysis tool again. It started many years ago for tooling for C++, now supports Java, PHP, Python, Ruby, JavaScript, maybe a few more languages. They are trying to find something they call common weaknesses, which other tools also try to discover. Some of them may have security implications, others are just plain simple bugs. For example, null pointer dereferences or null pointer exceptions. These are considered to may have impact on your security. And I will show you some examples. Unfortunately, from our project, Coverity did not find anything which is directly related to security. And also part of that is we implemented Coverity after we fixed all the problems discovered from Bandit. So maybe we were just lucky. But this one is, this is JavaScript. The problem with this piece of code in the red is that it's never going to execute. The first part of that is going to be converted to a Boolean, and then we compare Boolean to a string, which is always false. And this piece of code is not executed. Coverity will find lots of these, logically dead code. Another thing it found for us is expression without effect. And I had to Google what is use restrict in JavaScript, because I didn't know. And apparently that's some very old proposal that was never implemented. And the person who proposed it, they say on the website, they say, it is not very likely that a JavaScript engine will add a built-in support for this in the future. So effectively, it was dead the moment it was published on the internet. And on top of that, to be even more confusing now, there is a strict mode in JavaScript, which is documented, is part of the language, it's different. So confusing stuff, which I even don't have any idea what this can lead to. Another example from Coverity is this but use of null-like value or null pointer exception kind of problems. And the trouble with this function, so the trouble is here on this line. And we have this big fat if condition in the beginning, and we check the request variable. And the problem is that later, at the end, we still use the request variable, and it can still be none in theory. Sometimes, depending on how software works in what kind of environment, these variables will never be none. But sometimes they can be. And Coverity doesn't know, how your software operates, so it will tell you, you have a possibility here for this variable to be none. If you try to access a method or property from this variable, you're going to get an exception. Here is a better implementation of the same function. So first we make an if condition and check the variable, and then we make use of this variable if it is not none. This is a better implementation. Coverity will find lots of these. Another nice feature about Coverity, not directly related to security, is it keeps track of your identifiers and variable names. And if it sees something which is a little bit different, it will tell you, hey, you have a typo. So something a little bit different. The difference in these two examples is only one underscore. And this is specifics of the Django framework, how it can query fields in the database. The difference is one of them produces a join statement in the SQL, the other doesn't. They return the same information, so one is a little bit more faster than the other. But nothing critical here. Of course, Coverity will give you some nice charts, and I want you to pay attention. So this is the link to our project. You can look at everything that I'm showing. And I want you to look at this chart. So everything is going nicely until August. So we have about 70-75 issues detected in the program. And after that, they skyrocket. And the question is, what is happening? Why there is a sudden change in the number of problems in our application? And the reason is we have software dependencies. And having software dependencies, like we show in the beginning, especially when they are downloaded directly from the internet and not verified, this means trusting other people with your production environment. And that means you have to test this, you have to check it. All the tooling that I'm showing can be applied to the software dependency stack. All the techniques for designing test scenarios can be applied to software created by other people. And if you deploy this to your production environment, that means you trust these people. So you have to be careful. You need to know what is happening under the hood, under your application. So here are numbers to make things a little bit more scary. This is the number of problems found in our Python dependency stack, which is almost all of them. This is the number of problems found in our JavaScript dependency stack, which is about 1/3 of them. And these are the numbers of problems which still exist in the source code which we create. So only 2 actually, at the time I take the picture. So a lot more problems created by other people which we don't have enough control over that. It is much more likely our application to be exploited via problem, via bug, via security issue created by some other developer, not by our own team. So some numbers, Bandit found more than 4,000 issues in the Python dependency stack. Not all of them are problems, not all of them are critical in our context, but that means we have to examine 4,000 issues and decide what to do with them. Do we want to silence Bandit and tell them, hey, this is not a problem, ignore this? Or do we want to go on GitHub and fix the other library if this is a genuine problem? This takes a lot of time. We've not done this at all. I'm going to skip this, but these are the top 3 issues. In our context, none of these is directly related to a problem, but depending on how your application is used and how it is deployed, it can be a security concern. So Bandit doesn't know this, and it will tell you, hey, I know this can be a problem. Make sure you examine it and make sure you decide what to do with it. Same thing for Coverity. It finds a lot of problems in the source code created by other people. And it will tell you, you have this thing, I don't like it. Make sure you examine it, make sure either you fix it or you need to be very careful if you want to ignore this. You need to know what you're doing. So again, I'm going to skip this. But this one is probably interesting, control flow issue. So we have if condition variable equals 0, return false. Then we have a bunch of other stuff that is happening. This variable doesn't change, by the way, in these dotted lines. And then we have the same if conditions again. So this is absolutely pointless. And Coverity will find a lot of these. Next, moving on to another application that we work on. It's called Welder. It's available on GitHub. It allows the user to select some software, and it can build different images from cloud images, so Amazon image, Azure image, bootable Linux image, and stuff like that. As you can see, it looks very modern, very nice. It is built in React.js, pure JavaScript on the front end, and there's also backend component. Because we use JavaScript, there is a tool called npm audit that was announced in the summer of this year. Very good tool. It will examine your package JSON, and it will tell you if you are using something which is an older version, if this older version is known to have some kind of security problems. It will print links on the website, and you can go ahead and read about the problems if you don't know what they mean. And on the day npm audit was announced, we immediately ran this against our software. It discovered 10 issues, 2 high severity, both of them coming from jQuery. And the most ridiculous issue is that we had 2 different versions of jQuery in the same project. So how can we have 2 different versions of jQuery as dependencies in the same project? Of course, we worked to fix this, to unify our dependencies, to upgrade to the latest versions. If you use GitHub, GitHub also has a similar functionality. On the Insights tab, there's the dependency graph menu, and it will scan your package JSON, or for other languages as well. It will tell you what dependencies you use. It will tell you if something is known to have security problem. On the Settings tab, you can even configure how you want to receive notification. You can add other users to receive notifications. Very good functionality. And this is the screenshot from Welder Web again. You see at the top. Same application on the same day. GitHub tells you everything is fine with this application. This is how GitHub is supposed to look like when it discovers problems. And in our case, see, no problems. GitHub is fine. npm audit tells you there's some problems. Moving on to the other tool that we have. It's called Snyk. This is a London-based startup that is provided software as a service. If you have a public repository on GitHub, it's free to use again. They integrate very good with Node.js applications, and they also support Python and other languages, but the integration is not very good. Regardless of that, what I like about Snyk is that they are one of the few companies in this security scanning space. There's tons of tools available, but only few companies keep their own security research stuff at all times. And Snyk has their own security vulnerability database. That means they are able to show you more information which other tooling and other vendors are not able to show you. In this example, we have this cross-site scripting. In other projects, we had examples where Snyk showed us a problem 1 week before GitHub detected the same problem. So 1 week in advance, we knew that there was an issue. So that's a good thing. And the lesson here is don't trust your tools, or don't trust only one of them. Try to enable as many as possible because they give you different information. They work differently. Different vendors keep different databases up to date. So I try to enable 5, 6, 10 toolings. Whatever is available to me, I will experiment with it and I will enable it in CI. And over time, we decide if we keep it running or we don't like it and remove it. But don't trust only one tool. Find many tools. To keep up to date with everything, this dependency here, we use these robotic services, and the truth is you don't really need to use them. You can design this in a simple script that runs in Jenkins, and it will update your software whenever something is available. The good thing for us is these things, they're robots, they open pull requests on GitHub, and our tests run automatically. If we're happy, we can merge immediately. It just speeds up the process of updating things, especially when there's something bad going on. Last day, at the speaker's dinner, I learned about this tool called PVS Studio. It's a Russian tool. It's not open source, unfortunately, for me. They support C, C++, and I think C#, and I think Java. And Andrei will have a talk in the main room at 5 o'clock. So I talked to him, nice guy, knows what he's doing. So if you're interested, you can continue later on the same topic. There are many, many tools available. Here's a list of some of them. Haven't tried most of them. Also, OWASP, this is the #1 go-to place for open source tooling that has to do with security. There are also many, many tools available in OWASP. These are the ones which I think are interesting for me. Also, this one we tried, looks promising, found some cross-site scripting problems. And also this one, which I don't know how to use. But if you're a JavaScript expert, maybe you can tell me what this means after I'm finished. So let's move on to infrastructure. Because you saw software is bad, software dependencies are bad. However, infrastructure is also software. We can apply everything that I say to infrastructure. And what we do when we have a new project, your boss will come to you and tell you, hey, I like how you work. You're my most senior people, or you're the most technical person on the team. Here's this new project that the company is doing. I want you to be responsible for testing. But oh, by the way, we cannot give you a dedicated sysadmin for your testing environment. You have to create your environment by yourself, and you have to maintain it by yourself. And make sure this is up and running, because tests need to be running all the time. And maybe they need to be 100% automated, which is a thing nowadays. People love to be automated. And you don't have time to deal with this shit. Your job is to create tests and to make sure the software is fine. Your job is not to update Jenkins every day. Option #1, you go for the cloud. Find a service which is relatively cheap, start use it. In this example, this is Atlassian.net. Some company uses Atlassian.net. This is their wiki page and their employee directory. This is directly accessible from the internet. I did not try to brute force any passwords or nothing like that. I was given from a public page in their wiki, and I tried to click around just for fun, try to delete the address in the browser address bar and move one directory up and click on some of the links, and I was able to discover this page in 5 minutes. So all the people, emails, pictures, phone numbers, names, everything. Next, I move on to explore, and I found their retrospective meetings, and they talk about some problems with the team, and in this column here, they say, not having enough work in the team, unevenly loaded team members, we spent more time on the feature than we should, we are not persistent in decision, we decide something and then did not follow up. And now, when I know which people are on this team, I can target them, and I can try, to do something bad to them, if I want to. Not only that, but I can find their release schedule for the latest product. And I found this in January, and I've monitored the company until the spring when they release the product on time. So very bad. No, information leakage is bad. That must be secure. But this makes me think, if your wiki page is so ridiculously insecure, and you paid a cloud provider but don't validate what the default settings of the software are, then what else you don't validate? And my answer is your Jenkins infrastructure. So if you go to GitHub, GitLab, other places where people store source code, you will find a lot of projects which have a combination of public and private CI infrastructure. So public for a lot of projects is Travis CI, which is very popular. and private usually means Jenkins. And you cannot access the Jenkins slave directly, but you see the status is reported on the pull request or on the commits, and you see green, red. So in this project, I send this pull request, and we are going to look at it into more details. So this is what it does. It's a bash script to use for testing. It modifies the import program from something which is in the local directory to something which is on a system-wide directory, because I'm told by the developers, now this is available on the Jenkins slaves. Don't compile it locally. Use it from the system-wide directory. And we do some testing here. At the end, we have this cleanup. So we remove temporary files and directories. And the first time I submit this pull request, I forgot this thing. So I forget to update the last line. And we are effectively left with the line in red, which at the end removes the import program. So what happens? Two things happen. First, I submit my pull request, and all the Jenkins jobs, they start running, which means I have access. I am allowed to execute source code via the internet on these private systems. That means I have access to that. The next thing is the Jenkins job removes the import program. It reports passing result, and the next time I update my pull request, the Jenkins job fails because the import program is now removed. It doesn't exist. So the subsequent jobs fail. But again, this program is on a system-wide directory which is accessible only by root, which means I have full privileges on the test system. I can do anything I want. So the obvious thing is I can open up or modify this pull request, create a connection back to my computer, use this connection, jump on the slave, and from the slave go on to the Jenkins masters, and I'm into your company network. I can do anything I want to. And apparently, a friend of mine from IBM told me that the coolest thing right now is not to hack people, but to make their computers mining Bitcoins. So that's what people try to do right now. The lesson here is, especially with Jenkins, but it applies to any kind of infrastructure, testing infrastructure is a target. Make sure you configure it properly. Make sure you know how it behaves. So validate who can access, who can start testing jobs. Only trust people on your team or maybe people with an address from your company. Don't allow people from the internet to send you arbitrary pieces of code and you execute this blindly. And also make sure you test it. This is best done with automation. Because software can change. Somebody can upgrade the version of Jenkins and there can be a bug in your plugins. They can change behavior, or somebody will change the configuration, and again, this can change behavior. If you validated it was secure today, that may not be the case tomorrow or next week. So that's the lesson here. Pay attention to your testing infrastructure because it's very easy to exploit. And last, I want to leave you with an idea about the user. Because it doesn't matter how much we invest in tooling and infrastructure, the weakest point is always the person who uses the application. Because we people, we are absolutely terrible at passwords. We use the same password for different accounts because we like it and we don't want to invent a new password. We use weak passwords. We write our passwords on sticky notes on the computer, or we send passwords to our coworkers by email, by Slack, other types of non-encrypted media, usually telling, hey, I have this problem, can you log into my desktop and fix it? This is what we do every single day. And the good news for us, and also bad news for us, is that system architects and developers, they are also terrible at passwords. Sometimes they design a system which doesn't allow us as users to be secure even if you wanted to. This is a payment provider in the US, and they limit your password to only 15 characters. 15 characters for a payment provider is nowhere near the length of password I feel like comfortable with. And what we can do as testers is we can take part of all of these design sessions. We can take part in user experience sessions to examine the workflow in the application. We can take part in with the developers and architects into application architecture sessions just to learn what they think about the application, how they want to build it, how they imagine the user will be using the application. And we can use our analytical mindset, our skills to analyze, and we can tell them, hey, that's a problem. I think the user will not like this, and they will try to work around. The way to work around is create a very simple password, put it on the desktop. So we can tell this to our people on the team, and we can design better applications. So to summarize, because I'm already out of time, always inspect your source code. There are hundreds of tools available for different programming languages. Experiment with them. Find the ones which you like and you think work best for you. Inspect other people's code. Treat all infrastructure as production. And remember, infrastructure is also source code, so you can apply everything, even to infrastructure, and you can find yourself work for the next 10 years. And last but not least, remember that if we can create an application which is usable, doesn't prevent the customer from doing their primary job, if the customer is happy, they will not have any problems adopting any kind of technology security solutions that we propose to them. So thank you very much. Now time for questions.
Thank you, Alexander. We have 10 minutes for questions. Пожалуйста, поднимайте руку. Я дам микрофон. Ну, смелее, пожалуйста.
In the back. In the back, we have a question.
Hi.
Hey.
You have mentioned on the previously on I don't remember, maybe 10 or 11 slide that we cannot trust dependencies from side packages. Maybe there is some kind of list of trusted dependencies for Python for version 2 or 3. Mm-hmm. Some dependencies that, some list that can guarantee us that this dependency is secure or secure enough for our project.
No.
No?
I will stop you. No, absolutely no. Okay. Don't trust people on the internet, period. Now to give you a better answer. If you use a commercial software, let's say from Microsoft, then you pay them money and you trust them to pay attention to this software to make it secure. Maybe you use the .NET framework. This is one thing. On the open source world, if you pay Red Hat for Linux and for other software, you are guaranteed that we do testing, we do security evaluation of everything that we ship as a product. So this is a little bit more secure, this is a little bit more trusted. In the older days, what we were told as developers, if you want to build a web application, you have to use the software that is available with the Linux distribution, because this is at least somehow guaranteed it will be working, it's somehow secure, or even if it is not, we have people who we pay and it's their job to fix them. Nowadays, people ignore this, and what they do is npm install, pip install, rubygem install, or whatever install, which comes directly from the internet. You have no control over, everybody can publish stuff on the internet. There's not a single vendor that you can hold responsible for this thing. You don't pay them money, so how come you expect something to be secure? When you use open source, you can be relatively fine with big project coming from big groups like Python Software Foundation, the Python maintainers. It's a big team. You cannot get commit access very easily. Apache Software Foundation, the same thing. OpenOffice, LibreOffice, the same thing. So big groups, big teams, they have processes in place, and you have to contribute for a long time until you're given commit access. First, you can commit only on one project, on maybe only on one component in this project. And after time, you get more and more freedom, and you can do more things. But if somebody is very determined, they can wait patiently for 5 years to get access to the Linux kernel, and then they make a release which contains something which is very bad, and they affect millions of people. So don't trust people on the internet.
Пожалуйста, еще вопрос.
Hi, thank you for the presentation. How often do you run your tools, for instance, for each pull request or weekly, and
all the time.
How do you react?
So on the projects where we have enabled these tools, we run them pretty much all the time. We use GitHub for everything. We run them on pull requests. Some of the tooling, let's say Coverity, takes a long time to execute. Bandit sometimes also takes a long time to execute. We run them on, so we run these for the application itself every time, on every pull request, on every commit. And for the dependency stack, because it takes longer, we kind of don't feel like waiting 15 minutes. We run this only on the master branch, but again, on every commit on master branch. And the thing is, computing power is very cheap. So you can afford to buy cloud infrastructure that runs this for you all the time. And now there are very big software projects which have huge testing matrices, something like 30,000 test jobs on every single change. This is not practical, but you need to find a middle ground depending on how your software is organized. Yeah.
Can you tell us about working in conjunction with your dedicated security team? Maybe, people conflicts, because people are jealous when you do their job. Can you tell us a story about a conflict when security people tell you it's not a bug, it's a feature?
Yeah, I can tell you stories, but not the ones you want to hear, because I don't have them. So we do have a dedicated security response team at Red Hat, as does almost pretty much every bigger company. Their job usually is very different from what we do. These are the people, so-called pen testers, penetration testers, and they look at everything, infrastructure, how the customer can access our infrastructure, how they can access the software, etc. And usually the problems they find are very complex, something that we don't think about. They are also involved in security audits to get certification from some government programs. And this is a very specialized job. Even for some things, we use an external company that is out of sync. So they do their job, whatever they find, we fix it as fast as we can. It doesn't block the release schedule of the product. They are more than happy for somebody else to use tooling and to help them with this job. But the truth is, they are highly specialized, so we can never reach their level of specialization. The other thing that we did is, most of you have heard about bug bounty programs. They are programs for researchers and the community to disclose security-related problems to the company. From the testing point of view, I have been part of such program. And what we testers do is we receive information from an external contributor, and they say, hey, maybe on this page, I can exploit these cookies and gain access to the username or to the password in the database. Our job is to validate the reproducer, which is the same thing we do when we have bug reports. First, we validate the reproducer, and then we try to create an automated test case in the language and the frameworks that we use for this product, which is not always the same which the researcher uses. So this is our job in terms of how we interact with the security response team.